In this demo, we demonstrate semantic interoperability in smart spaces composed of high and low capacity nodes. This is the general overview of the demo setup. We have the high capacity network on the left hand side and the low capacity network on the right hand side. In the low capacity network, we have a RMGWKP, Resource Manager Gateway Knowledge Processor, which is responsible for managing the low capacity network, and also it is a gateway to the high capacity network. The low capacity network uses OSAS, Open Service Architecture for Sensors, which is a framework designed for providing an integrated approach to program sensor networks, especially the ones that are composed of low capacity miniature devices. OSAS is developed in System Architecture and Networking Group at Eindhoven University of Technology. This is OSAS simulator running on a computer. On the left-hand side, it has the list of addresses, services and subscriptions that are installed by the loader to the nodes. On the right-hand side, we have the simulated nodes and the screen that prints specified information related to the network. The miniature wireless devices that are shown are the low-capacity nodes in the network. This is the loader node that establishes the communication between the RMGWKP and the nodes. These are the nodes in the low-capacity network which are responsible for producing light intensity data. Node 1 is with ID 52 and Node 2 is with ID 54. This computer contains the SIB, Semantic Information Broker, which is a common database for both networks. It also contains an RMKP, Resource Manager Knowledge Processor Unit, which is responsible for managing the high-capacity network. This is a consumer KP which is represented as a lamp that uses the light intensity data gathered by the nodes. PKP1 and PKP2 are the producer KPs of the high-capacity network that are capable of measuring the light intensity. Now we will demonstrate our proposed failure detection and recovery solution in this interoperability architecture. In the demo, in order to recognize which KP provides the light intensity to the consumer KP, we use three different colors to represent each producer KP. Green color represents RMGWKP, which receives the sensor readings from the low-capacity OSAS network. Red color represents producer KP1 and blue color represents producer KP2. The system starts with the initialization of the consumer KP. As stated, green light indicates that the light intensity information is received from the low capacity network. Only the node with ID 52, also known as node 1, producing light information. As indicated, the light output of the consumer KP changes according to this node. The other node with ID 54, also known as node 2, is not providing information as shown. After that, we move node 1 from the coverage area of the low capacity network. As shown on the simulator screen, node 1 does not provide information anymore, and after the timeout period, it leaves the system. Just after RMGWKP realizes that node 1 is absent, node 2 starts to provide light intensity data to the system. It can be seen by observing the change in the light output. After a while, node 2 also leaves the coverage area. When we zoom into OSAS simulator screen, we can observe that node 2 is also not producing light data. After RMGWKP realizes that node 2 also left the system, OSAS part cannot provide data anymore. Hence, RMKP chooses PKP2 as a provider, which is indicated by blue light. This can be observed by the change in the light of the consumer KP. After this, producer KP2 also leaves the system. Then, RMKP realizes this and chooses producer KP1 as a producer indicated by red light. Afterwards, producer KP1 also leaves the system, and this means that there are no providers left in the whole network. At this point, the system is configured to stay in the last state until a provider joins. Then, Producer KP2 joins the system and RMKP directly chooses it as a producer. Producer KP2 again leaves the system and the system stays in its last state. Finally, an OSAS node enters the coverage area of the network and it gets recognized by RMGWKP. After RMKP realizes that RMGWKP is capable of producing data again, it directly receives data from it. This concludes our demo. Thank you for your kind attention.